Hello everyone. Today we are going to be going over Unit 2, Lesson 3, Multiplying Powers with the Same Base. So we're going to start off with this question that hopefully a few of you enjoy. It says, Deadpool and Spider-Man are taking a math test with the following question. Write 3 to the fourth times 3 to the second as a product of threes. What is the question asking them to do? So I have a thing that I got from the internet there, so hopefully you enjoy that. But the problem itself says write those two things as a product of threes. So product means multiplication. So product of threes means that we're going to be multiplying threes a lot. So if I take this 3 to the fourth, another way to write that as a product of threes is 3 times itself 4 times. And then if I'm multiplying that times 3 times itself 2 times, then that means I would write times 3 times 3, 3 times itself 2 times. So altogether, I'm multiplying 3 by itself 4 times and then another 2 times. So altogether, between those two things, I get 3 times itself 6 times. And you may already see the pattern when you compare the 3 times 4 times 3 to the second, and you end up with 3 to the sixth power. So you may already see the pattern. But if you don't, the pattern is that if you're multiplying powers with the same base, so up here we were multiplying 3 a bunch of times, as long as they have the same base, you can multiply them by adding the exponents. So just like we had 3 times itself 4 times and 3 times itself 2 more times, another example is if you have 10 to the third times 10 to the 11th, all together you're multiplying 10 times itself 14 times because you've got the 3 times and then 11 times. So all together it's 10 times itself 14 times. So again, as long as they have the same base, you can multiply them just by adding the exponents. So then all of these should move pretty fast. If you have 8 to the third times 8 to the sixth, you add the exponents and you get 8 to the 3 plus 6 gives me 8 to the ninth power. If I have 0.5 to the power of negative 3 times 0.5 to the power of negative 8, again I add the exponents and I end up with 0.5 to the power of negative 11, because if I have negative 3 plus negative 8, altogether that's negative 11. I can think about that as starting at negative 3 and then moving 8 to the negative side to the left, and altogether it's negative 11. And then this last one has 3 different bases, but altogether I'm still doing the same thing. I have 9 times itself so many times itself so many more times. So I'm still just going to be adding all the exponents together. Some of them are negative and some of them are positive, but I still just add them all together. So 9 to the power of negative 3 times 9 to the power of 2. Well, negative 3 plus 2 gives me negative 1. Negative 1 plus 6 gives me 9 to the power of positive 5. And if I want to double check that, I can combine these last two first. So 9 to the second times 9 to the sixth would give me 9 to the eighth, and then add negative 3 to that, and then that would give me 9 to the fifth once again. So all of these do not need to be simplified any further because all you're trying to do is write it using each base only once. So you've got one base and one exponent to simplify. Now moving on to problems that include variables. So the way that you do these is you're going to multiply the coefficients just like you would normally. So just like you would multiply like 3x and 7x, you multiply the coefficients together because those are like terms. Because really what's happening here is I'm just multiplying all of these terms. I'm multiplying 3 times x to the fourth times 7 times x to the negative ninth. And we know from one of our properties that if you're just multiplying things together, like as long as there's no addition or subtraction or like anything other than multiplication, if you're just multiplying, you can multiply them in any order that you want. So you can sort it in any way that simplifies it. So I'm going to multiply the things that are the same. So I'm going to multiply the 7 and the 3 and get a coefficient of 21. And then next I'm going to multiply my variables. And so my variables have the same base, so I can only do this because they're both x to a power. and they're being multiplied together. So if I have x to the fourth and x to the power of negative 9, if I add those two exponents together, I get x to the power of negative 5. So if I multiply those two terms together, I get 21 for my coefficient, and then x to the fourth times x to the negative 9th gives me x to the negative 5th. Now this one is going to look really complicated, but it is just the same stuff that we've already been doing. So the first thing that I want to look for are coefficients, and that is going to be real easy because, well, first of all, I want to make sure that I'm only multiplying, and all of these terms have multiplication symbols in between them, and there's no addition or subtraction or anything other than multiplication. So I check that off my list, and now I'm looking at coefficients, and there's only one of those, so I don't even have to multiply it by anything. It's just negative 6. So carry that down. And then why not start with the x's first, because that is the first one listed. So I'm going to go through and highlight all of my x terms, all my terms with x as the base. So I have x to the fifth, x to the negative second, x to the negative fourth. So 5 plus negative 2 gives me x to the third. Yep, positive third. And then if I add negative 4 to that as well, positive 3 plus negative 4 gives me negative 1. And just in case, I'm going to use, I know it's right, but I'm going to use my OneNote to calculate it anyway. 5 plus minus 2 is the same thing as minus 2, plus minus 4 is the same thing as minus 4, equals, yep, negative 1. Never hurts to double check. And then, next, we're going to do my y terms, and there's only 2 of those. So if I have y squared times y to the negative 8th altogether, that is going to give me y to the power of negative 6. 2 plus negative 8 gives me negative 6, and so this is going to be my final answer. All of those terms have been combined. So it took that really messy thing and turned it into a relatively simple algebraic expression. All right, next one. So even though these are in parentheses, it still just means multiplication. So really, the parentheses don't even need to be there. They're just all being multiplied. It's only multiplication. Again, if there was addition going on, it would be a completely different thing. But because there's only multiplication going on, I can still just simplify by combining like terms by multiplying. So I'm going to look for my coefficients, which this time I have a 3 and a negative 8. 3 times negative 8 is negative 24, but I'm going to double check just because that's the state of mind I'm in right now. It's just being real careful and double checking. Okay, negative 24 for my coefficients. Next, I'm going to do my m terms. So I have an m squared and an m to the negative 4th. So if I add 2 plus negative 4, that gives me m to the negative 2nd. Next, n to the negative 5th times n to the 10th, negative 5 plus 10 gives me n to the positive 5th power. So that would be my answer for that one. Pretty simple once you get the hang of it. So one way that exponents are used a lot is in scientific notation. Now, this used to be a little bit more important than it is now because we used to have to do all of our calculations by hand, or they didn't trust the computers enough, so they had people do these calculations by hand at NASA and all those sciencey places, but it is still a quick way to do these kinds of calculations. It is actually a lot easier than putting them back in regular notation and multiplying them in a calculator. This way is actually much faster, so definitely worth knowing. So I am still just multiplying all of these terms, right? I have 2 times 10 to the 6th, one number in scientific notation, 3 times 10 to the 3rd, another number in scientific notation, but all of this is just multiplying. So I can multiply them in any order that I want, because math says I can. So I multiply 2 times 3 and get 6, and then I'm going to multiply my So those are kind of the equivalent of coefficients, right? I'm multiplying 2 times something to a power, so I can multiply those, and then I'm going to multiply my tens. So I have 10 to the 6th times 10 to the 9th, and altogether this is going to be 6 times 10 to the 9th power. I think I said 9 instead of 3. 6 and 3, add them together and you get 9. So I get 6 times 10 to the 9th, and because I only have one digit here, the 1/6. I don't have to do anything. It's already in scientific notation. So I've got a number with one digit before the decimal point. You can think of this as like an imaginary decimal point. And it's multiplied by 10 to the power of something. So this is in scientific notation. And then we'll just do this one more example, and then I'll finish up this video. I know it's a little bit of a longer one. So I'm going to multiply the numbers that are sort of like coefficients, the numbers in front. 1 times 3.4 happens to be really easy. 3.4 times, and then multiply my tens. I have 10 to the 3rd and 10 to the -8th. So 3 plus -8 gives me times 10 to the power of -5. And that's it. Way easier than putting it in your calculator. Alright, so that is it for this video. If you have any questions, feel free to reach out to your respective teachers, whether that's myself or one of the other Algebra 1 teachers. Hopefully this helped, and let us know if you have any questions.